One of the new features we've shipped under the GoldRush API is support for internal transfers and traces. So let's understand why this is necessary and what kind of capabilities it unlocks. If an asset moves from wallet A to wallet B, and if this asset were a fully compliant ERC20 transfer or ERC20 token, then every ERC20 token transfer emits a transfer event. And the transfer event has a signature of a to, a from, and the amount. Now you have to decode the amount with the decimals and so on, but you know that an asset has moved from point A to point B. Now there are some cases where you don't have a transfer event. Majority, I would say 99% of the use cases, you have a transfer event, and so you can just decode that transfer log and figure out, okay, an asset has moved from this wallet to this wallet with this quantity. An example here of where there's no transfer event is the ETH native asset. So the gas token or Ethereum, the ETH token. So this token went live as soon as the ETH mainnet went live. So this would have been about 10 and a half years ago. But the ERC20 standard only came a year and a half after mainnet went live. So what that means is that if I transfer ETH from wallet A to wallet B, there is no associated transfer log. It just doesn't exist. So the only way you can get this is through internal transfers or traces. Another use case is that these transactions on EVM chains like Ethereum have become so complicated that you're able to create meta transactions, bundle transactions, account abstraction, all kinds of abstraction layers. What that means is that even if you had a transaction with a to and a from, it may bundle dozens of other transactions and have all of these internal functions, internal transfers that may or may not emit transfer logs. And so you want to decode all of those transfer logs. So this is the primary kind of use case. And these traces are actually not stored on chain. They're the byproduct of re-executing a transaction. Now, GoldRush has historically had trouble supporting these internal transfers. And the reason for that is primarily because of the amount of storage that these traces take. So on a blockchain, let's say on a base blockchain, your blocks and your transactions and your event logs and other kinds of associated objects probably takes about 20 terabytes. But if you add traces, that storage space balloons to over 100 terabytes. So that's like 5x growth. So what that means is that from a compute layer and from a storage layer and from the cost of transferring this data, you have to rethink the architecture. Fortunately, this is a architecture we've been building for the last couple of years. And so now we're able to scale to rise and meet those needs.